Hi guys, welcome back. So in this video, we are already in part 4 of our lesson. So we have the standard forms of the ellipse. Let's go to the next slide to start. The standard forms of ellipse. So there are actually two standard forms referring always or basing always uh, in our major axis. So if our major axis is horizontal, so it indicates that the ellipse is also horizontal. Okay, so let's try to draw here. Okay, so the ellipse, so the major axis is horizontal, the ellipse is horizontal. Or if we have here, the major axis is vertical, so the ellipse is vertical. Okay, so these are the two equations. So we have here quantity of x minus h squared over a squared plus the quantity of y minus k squared all over b squared equals 1 for the major axis is horizontal. Okay, this one here. Then for the vertical, we have y minus k, quantity y minus k squared over a squared plus the quantity of x minus h squared all over b squared equals 1. Okay, so take note that a is greater than b. Okay, a is always greater than b because a is our major axis for the ellipse. So take note that the major axis for ellipse is always the longest line segment. So this in an analysis of the equation, it means that if the squared of the length of the major axis is at the bottom of the horizontal part, so take note that x and h are all horizontal. You can remember in our previous topic in parabola, x and h is pertaining to the horizontal, and it happens at the longest or the longest segment, the square of the longest segment is under it at the denominator of the horizontal, the ellipse is horizontal. Otherwise, if the longest length, which is the semi-major axis, okay, a squared, is at the vertical, under the vertical, this is the vertical, can you see it? I just go a little bit, yeah, okay, so the ellipse is vertical. So you just need to remember this. Then just get an understanding that whenever a is at the bottom of the horizontal, it's the ellipse is horizontal, and whenever a is at the bottom of y and k, which is the vertical, the ellipse is vertical. Okay, so let's go to the next slide for specific explanations. So let's discuss the first form and what are the important elements that we need to know in this first form. So the first form, okay, so try to look at the given. So our A is under X and H. So X and H is horizontal, so this means that our orientation is horizontal. So the very easiest element to discover is the center. So center is just H and K. So similar to the circle, okay, similar also to the parabola. So we can always find the center, okay. Then length of the major axis. So what's the length of the major axis? So the entire length of the major axis is just twice A, or 2 times A. And for the minor axis, okay, so again, minor axis is B. So twice of B. So this is the entire length of the minor axis. Focal distance, so C equals the square root of A squared minus B squared. Now for the foci, there are two foci, okay, that we need to solve. So if it's horizontal, take note, horizontal, so we always add or move, okay, just imagine it's moving, okay, moving in the horizontal part. Hence, we add or subtract h. Okay, so this is the reason why it's here, because we moved leftwards or rightwards. So add and subtract c at h. Okay, now the vertices. So the vertices is always dependent on the orientation or the major axis. Okay, so if the orientation is horizontal, you add a. Okay, you add a to your horizontal part. If it's okay, for later on for vertical, it's the other way around. And then for the co-vertices, so the co-vertices always refers to the minor axis. So the movement in the minor axis is referring to b. So we add or subtract b. So the distance here, if you try to look at the graph here, so it's this. So the distance here is actually b. So b. So add minus b. So plus b minus b. Okay, that's the co-vertices. Okay, so we have this notation. So v1 and v2 is for the vertices, v3 and v4 is for the co-vertices. Then we have the endpoints of the latera recta. So we have the latera recta here. I'll just try to erase for a while. Let's try to erase. Okay, so where can we see the latera recta? So the latera recta always pertain to the focus. When we talk about latus rectum or latera recta, it is dependent on the focus. Okay, so the latera recta passes through the focus. Sorry, it's not really that here. Okay, so that's okay. So that the green line segment is the latera recta. Okay, so of course, if there are two latera rectas or two segments, we have 4 endpoints. Okay, so that's why we have 1 and 2, 3 and 4. Okay, so how do we get it? We simply add and subtract b squared over a, b squared over a. So further explanation on how to find the endpoints of the latera recta will be given on the example. Okay, then we have equations of the directrices. So we have two directrices. Okay, so it's not actually written in the graph because the graph is so small. So we have here as our directrices. Okay, so for the directrix, it is always dependent on the orientation. So the orientation is horizontal, hence our directrix, we have x and h. So we have x sub 1 equals h plus a squared over c, and we have also x, or x sub 2 equals h minus a squared over c. Okay, so those are the important elements we need to find if it's horizontal. Now let's go to the vertical part. Now we're at the vertical form of the ellipse. So how do we know that it's vertical? Always refer to the equation. So our equation is our A. Okay, our A is under y and k. And remember, y and k is vertical movement. Hence, the orientation is vertical. So we know the center, it's just hk. Okay, so it's the same for the length of the major axis and the length of the minor axis. It's just 2a and 2b. For the focus, they're the same. Okay, so what are the elements that we need to look at? Okay, so just observe the focus. So now for the focus, since the orientation is vertical, okay, again, the orientation is vertical here, okay, we add our focal distance at the vertical part, which is k. Okay, so from the center, plus or minus c, and we add it or subtract it at k. Okay, so if you try to look at the graph here, so it's here, this part here. Okay, this part here. This is the distance c. Okay, then for the vertices, okay, now the vertices is vertical. Okay, because our orientation is vertical. So here we add our A at the K part of our point. So add A or minus A because there are 2 points. So let's see. This is our V1 and V2. Okay. Then for the vertices, it's the other way around. It's the opposite. So if you add and subtract at the vertical part, for the co-vertices, we will add or subtract B at the horizontal part, which is this part here in the graph. Okay. Then for the endpoints of the latera recta, again, the latera recta always refer to the focus. So it's here. It's the line segment that passes through the focus. Okay, so it's here. So we have 2 endpoints for this here for the above focus above, and the another 2 points at the focus at the bottom. Okay, so you will add at the horizontal part. Okay, why horizontal? Because again, the endpoints are found at the horizontal or move horizontally. Okay, so just add b squared over a, same, it's the same. Okay, then for the directrices, still the same. What changes is the variable. Instead of x and h, we have y and k because again, vertical. So I think that's for this point. Okay, so take note that the most important part or elements of an ellipse are the center and the lengths A and B. Okay, so why do we claim it? Why do we say that this is true? Okay, so let's try to write our elements. So for example, if we have center, okay, so our center is just HK. And if we have A and B, okay, so if we have HK, A and B, we can focus on A and B, and using the formula for the focal distance, you can get C. And if you have A, B, C, H, and K, you can always get all of these. Okay, so try to observe the elements. So we just have H, K, A, and B, and C in our formulas. Okay, so that's why this is true. And that's for the standard forms of the ellipse. See you in the next video for the examples.